The next thing we're going to look at with matrices is what's called an inverse of a matrix. So if we multiply two things together and get back the identity matrix, we're going to consider that an inverse. And let's think about that. So like 1/2 and 2 are inverses because if you multiply them together, you get back 1. Same idea here. So if they are inverses, then when you multiply them together, you should get back that identity matrix that had the 1s all the way down the diagonal. So let's look at these two, and I'm going to help us do this a little faster. We're going to go into the matrix and edit A to be a 2 by 2 with 1, 2, 1, and 1. Go back into the matrix, and we're going to edit B to be a 2 by 2 with -1, 2, 1, and -1. Whoops. And then remember, to do any kind of calculations, we need to quit first. And then we're going to do matrix A times matrix B. So if I multiply A times B, I'm getting 1, 0, 0, 1, which is the identity. Let's see if the order matters. So we want to check the other way as well, because remember, order does matter in matrices. And I get the same thing. So these are inverses. Yes, they are. So that's how you test to see if you have inverses. Well, what about finding an inverse? Well, finding an inverse with the calculator is one way to do it. So we'll do that with this one. So I'm going to go back into the matrix, edit A to be a 3 by 3, 2, 5, 4, 1, 4, 3, 1, -3, -2. Now I'm going to quit because I want to do something with it. So we're going to go back into the matrix, and we're going to go to math. No, we're not. Oh my goodness. Okay, we're going to go back into the matrix and pull up A. Inverse is denoted by that -1 in the exponent. And if you notice, the matrix is on top of my inverse button. That's the inverse. So I'm just going to press that, and now it's going to give me a new matrix. -1, -5, 7, 2, 8, -11, 1, 2, -3. And let's prove that that is the inverse of A. So I'm going to times that by A, and I get my identity. Now there is a formula to find it with a 2 by 2 matrix. So if you didn't have a calculator, you could use this formula. And so the formula says we're going to take AD, that diagonal, minus BC, 1 over that difference. And then we're going to rearrange our matrix just a little bit. So let's look at how that would work. So for A, we're going to do 1 over this diagonal minus this diagonal. So 3 times 15, 5 is 15, minus 2 times 7 is 14. And then D and A switch places. So this becomes a 5 and a 3. And then B and C, they stay in the same places, we just change their signs. So that gives me 1 over 1. Oh, that's nice. And you could prove that by doing it in the calculator as well. Let's check this one. 1 over 2 times 2 is 4. minus 1 times negative 4, which would be a negative 4. So this is 1/8 of, we're going to switch the A and the D, which is still going to be 2, 2. And then these are going to switch signs. So I end up with 2/8, negative 1/8. 4/8 would be 1/2. And then, well, 2/8 would have been 1/4. But you get your matrix. All right. One of the applications of inverse matrices. Look at this. Back to that coded message from 3.2. All right. So let's say this was our coding matrix to encode the message. And we need to find the inverse of A so that we can uncode the message. So we'll do this one by hand, like just to show that process. 1 over 3 times 6 is 18. Minus 5 times 4 is 20. This diagonal gets switched, so 6 and 3, and then we just change the signs on the other diagonal. And that is 1 over negative 2. Which is going to give me, let's see, negative 3, 2.5, 2, and negative 1.5. Now, if I take that, and let's take, so we're going to do this inverse times the coded message. So let's see how we can do this in one step. I'm going to put the coded message, since this is a row with 2 items, I need to have 2 in each column. So 96, 118, 65, 84, 131, 168, 55, and 72. And I'm going to actually multiply that in the calculator because that's going to take some time. So go back into the matrix. A is a 2 by 2. And then I'm going to go back and edit matrix B, and that would be a 2 by 4. Quit. Now I'm going to take what I put in for matrix A, which was my inverse, and multiply it times B. And I get 7, remember how they were written before, that's 7, 15, 15, 4, 27, 10, 15, and 2. And if I look back up at the top, I'm going to get the decoded message from 3.2. Alright, well there's another use for inverses, and that's with equations. So this is another way to solve systems of equations. So let's say we have this system. And we could write it as a matrix equation. These are all the coefficients, these are the variables, and these are the constants. So let's think how this could work. If I called this A, and this X, and this B. Okay, so let's think about that. I have my coefficients times the variables equals the the constants over there. If I multiply each side of the equation by inverse of A, what's going to happen when I multiply the inverse times A? Well, that's just going to be the identity, or basically 1. So I'm just going to get X over here. So this is another way to do systems. So let's think about what would be our A. So we'd have, oh, this is the same problem. I didn't even realize that. 1, 4, 3, 1, negative 3, negative 2. That's going to go in as A. And the B is going to be 4, 1, 5. So that's going to be B. So my X, Y, Z is going to be found by doing A inverse times B. And it's going to give me a column. Watch this. Whoops, I hit the wrong button. Let me quit. Okay, matrix A. So my A is a 3 by 3. Go into matrix B is a 3 by 1. And I'm going to pull up matrix A inverse matrix B. And it gives me X, Y, and Z. So you have that option as well as the other method, and so we'll go on. The determinant of a matrix is that AD minus BC. And it's used so frequently, it does have the name determinant, DET, and the calculator actually has that as well. So if this gave me a 0, then I would not be able to find an inverse because I'd have 1 over 0. That would also mean that the system would not work either. So I'll show you how to find the determinant with the calculator. So we have this system with, how many variables is that? 5? Woo! You would not want to do that one by hand. So we have a 5 by 5. 0, 1, 3, 1, 0, 2, 3, 1, 0, 1, 0, 2, 3, 1, 0, 2, 2, 1, 1, 0, 0, 0, 3. So I can find the determinant of this matrix, and that's under the math menu, and it's the very first option. And it gives me a 24. So the determinant of A is 24. So will we have a solution? Yes, there will be a solution. Whoops, you can't see that. Let's find it. I'm going to go ahead and put in matrix B. Whoops. Go back in. Matrix B is a 5 by 1. 16, 2, 9, 3, 10. So if I'm using this method, I'm going to go do matrix A inverse and then matrix B normal, and I get a solution for each variable.